So we're going to finish off the regression section with this example that says we're going to compare the squares, the sum of the squares of residuals for a guess versus the actual least squares line. So I have some points here on this coordinate system. These are the coordinates of them. So 1, 2, 3, 4, that's the x. And the y's are 13, 14, 19, and 21. And I've drawn this line here as my guess, as the best fitting line. So the 2 points there are 1 and 12.5 and 4 and 20.5, like that. And so then we'll compute the slope. It's 20.5 minus 12.5 over 3. So we've got 1, 2, 3. That's the run. The rise is the difference in the heights. 20.5, that's good. Okay. And then 20.5 minus 12.5 is 8. Oh, look at that. Divided by 3. So 2.667, say, like that. And then we'll write the equation. We'll use this first point. Y minus the y is the slope. X minus the x, like that. So that's the point slope form. Y minus y1 is m. X minus x1. We're using that first point as our point. Okay, so far, this one here. Y minus the y, x minus the x, the slope is in there, okay. And then we'll solve that for y. So y equals 2.667 times x. And that's minus 2.667 plus 12.5. So I take 12.5, subtract off 2.667, I round it a little bit. 9.833 plus 9.833, like that. So that's the guess. And then we'll go into the calculator and we'll find the real regression line that's supposed to do a better job. I think I did a pretty good job though, even with my guess. So I'm going to go to Stat, Edit, and I'm going to clear out this first 2 lists. Clear, Enter, go over, up, clear, Enter. Don't use delete, it'll cause grief. The x's are 1, 2, 3, 4. And the y's are 13, 14, 19, 21, like that. And I'm going to go to Stat, Calc, go down to regression here. Oops. And then I tell it list 1, list 1, list 2, everything's good. X is list 1, Y is list 2. Go ahead and calculate. So the real answer is, well, a better answer maybe. 2.9 as the slope. X plus 9.5. Okay, so now the challenge is getting a hold of the residuals. I'll get out of here. So what I'm thinking is there must be some way to use the calculator to do this. So I'm going to keep track of what I'm doing here. So this is list 1, that's list 2. In list 3, we'll put the residuals from the guess. I haven't done this before, so this might be a challenge. Here we go. So what I'm going to do is, how do you get them? Well, you take the y's. What does it look like? They are y minus y hat, like that. So I'll take the y's. They're in list 2. I'm thinking hard now. So I'm going to go second to list 2. That's the y. And I'll subtract off then the equation applied to list 1. Maybe I should have parentheses there. Parentheses. 2.667 times what's in list 1 plus 9.833, like that. So I'm taking observed y, that's the stuff in list 2. I'm subtracting off the predicted y, which means I use the x value in the equation. That looks good. And then I'm going to store that in list 3. Is that cool or what? Now those are just the residuals. Let's just have a look at them though. Here we go. Something bad happened. I think I typed something. I put 9 minus 833. That's not good. Okay, we'll try second. Enter. Come back here. You can retype things. It is really supposed to be 9.833. Okay, and then we're going to store that in list 3. This might be better. So I was looking here. Those are the residuals being stored. Those are giant numbers. It should be something like a half or something. Oh, there we go. Okay, so now we're looking at those. So we're thinking the first point's about half a unit above the line. The second point's 1 and a bit below. The third one's 1 and a bit above. And the fourth one's half below. Okay, so we set it up to be that way with rounding. Because I put 12.5 here and 20.5 there. So exactly half off from each of those. But there was some rounding in when I rounded off the slope slightly. So up there I missed it by a tiny amount. So those are the residuals. So we'll look at them. Stat, edit. They're in list 3. Those are those numbers. Now we'd like to square them and add them. So I think when you go stat, calc, 1 variable, and I choose list 3, and hit calculate, one of the things it gives you is the sum of the squares. So in list 3, I've got those residual values, and so the sum of the squares is 3.220446, like that. Okay, that's for the guess. Sum of the squares of residuals. Kind of cool, we could do it that fast. And then we're going to use the actual equation, which is here, and do the same thing. I'm going to put that residuals in list 4. Here we go. So I'll get out of here. And then I'm going to take the y's, because it's y minus a new y hat, like that, using this new equation. So that's the least squares line equation out of the calculator. So I take the y's, that's second 2, subtract off parentheses, 2.9 times the x's, second 1, plus 9. Oh, I see what I did last time. I put a minus sign there, 9.5. And we'll store that. Look, the store guy's down here. I didn't show it to you. There's store right there. Store it. Now I'm going to put that in list 4. Go second 4. Enter. So with the new line, those are the new residuals. Now you notice this last number here is pretty tiny. So the least squares line has actually pulled the line up in that direction. And it's actually allowed this one to go a little bit down. And somehow that has, since it'll have slightly steeper slope, it'll fit these 2 points a little bit better. So we might gain overall. In fact, that's what we're thinking. So those are the residuals. And then this in list 4. And then we'll go stat, calc, 1 variable. And then I'll put list 4 in there. Go down. And now we see the sum of the squares is 2.7. You with me? Yeah, 2.7. Sum of squares, 2.7. So that's just an example of how the least squares line does a better job than you would think of fitting the data. So by steeping this, so what we did, what the regression line did is it balanced these two guys by sliding this one up, this one down. And what that did is bring these closer to these 2 points without losing anything on the ends, because we've compensated one for the other and got closer, right? So what you draw by eye isn't always what the regression line gives you, because it's doing a very specific procedure where it's minimizing the sums of the squares. So since these are pretty big numbers compared to those, when you square them, small gets smaller and big gets bigger. So we want to try to eliminate those big values if we can. At least that's what the regression line is doing. And there we go. Kind of cool. I showed you some stuff on the calculator. You might have to watch it more than one time because it's a bit the kind of arithmetic you can do using lists. A little hard to get used to, but there you go. And I'm going to stop this this video right now. It's the end of this chapter.